This is the screencast for section 3.1, example 3. So now that we've learned what a derivative is, we're going to explore derivatives like crazy. We're going to do things with them, apply them to real life. We're going to look at their graphs. We're going to look at how their graphs relate to the original. We're going to look at how to find a second derivative. Oh my goodness. Well, one thing at a time. First of all, the notation for a derivative. You can see 1, 2, 3, 4, all 5 of these at any point in time, and they all mean the same thing. So this first one is y prime, and this tends to be the trivial kind of shortcut way. Y prime just stands for derivative, and you saw it as f prime of x, so same thing. But this doesn't give a whole lot of information. dy dx, this is the big one. Eventually we will move to only using this one. dy dx is awesome because in the numerator it tells you what the output variable is, and then in the denominator it tells you what the input variable is, which will definitely come in handy definitely down the road of this course. df dx means the derivative of your function with respect to x. So again, x is your input variable, f is the name of your function. They might also write it as d dx and then kind of off to the side as almost a multiplication. They'll put f of x. And really it's not multiplication, it's a process. It's kind of like the sine of f of x or the log of f of x. We're doing the derivative of f of x with respect to x. And you might actually see, instead of f of x, you might see the actual function there too. The derivative with respect to x of x squared. So speaking of graphs of f and f prime, we're going to graph f prime from the graph of f. Our directions say graph the derivative of the function f, whose graph is shown in this figure. Discuss the behavior of f in terms of the signs and values of f prime. Well, one thing at a time. Let's graph the derivative first. Now, if you remember, the derivative represents the slopes of the tangent. So at a certain x value. So f prime is going to have x values as an input and slopes of the tangents as the output. So instead of x comma y, we're still going to call this y, but y represents slopes. So for example, at the x value 0, our original function f of x has a slope of a tangent 4. At x equals 1, the slope of our tangent is 1. At x equals 2, the slope of our tangent, this time it would actually be horizontal, a slope of 0. At x equals 3, the slope is going to be negative 1. So we might want to keep this in mind. Look at, we're supposed to discuss the behavior of f in terms of the signs and values of f prime. Well, we had positive slopes, we went to 0 slope, and now we're at negative slopes. So keep that in mind. This slope here at 5 is negative 1. Still negative 1, I guess. The slope at 6 is 0. And if you wanted to make a prediction, the slope here at 7 might be a little less than 4, maybe 2. So now we have all of the points on our graph of f prime of x. 0, 4, meaning the slope of our tangent lines at the x value of f is 4. 1, 1, 2, 0, 3, negative 1, 5 also negative 1, 6 0, and 7, and we predicted that to be about 2. So our f prime graph looks something like that. Maybe not as messy as mine is, but something close. So if we break this up into sections, let's look at where our slopes, because we're supposed to discuss the behavior of f in terms of the signs and values of f prime. Well, here we've got a slope of 0, and here we've got a slope of 0. So at 2 and 6, 2 and 6, the slope is 0. Before x equals 2, the slopes are positive. In between 2 and 6, the slopes are negative, and then after 6, the slopes are positive again. So we've got positive, 0, negative, 0, and positive. Do you see a pattern of what's happening? When our slopes are positive, what is the graph doing of f? When our slopes or derivative is negative, what is the graph doing? And when the slope is positive again, what is the graph doing? Well, if I look, when the slopes are positive, f is increasing. When the slopes are negative, f is decreasing. Which makes sense. If the graph is increasing, the slope is going to go up to the right. The tangent line is going to go up to the right, so its slope will be positive. When the graph is decreasing, the slope is going to go down to the right, be a negative slope. So in our discussion of the behavior of f in terms of the signs and values of f prime, I can say when f is increasing, f prime is positive, and when f is decreasing, f prime is negative. The now try problem number 23 gets a little wordy, so bear with me here. The graphs on the figure of 3.10a show the number of rabbits and foxes in a small Arctic population. They're plotted as functions of time for 200 days. So here's your time in days. Here is your population. The number of rabbits increases at first as the rabbits reproduce, but the foxes prey on the rabbits, and as the number of foxes increases, the rabbit population levels off and then drops. Figure 3.10b shows the graph of the derivative. So here's f of x, here's f prime of x. So this graph shows the derivative of the rabbit population. We made it by plotting the slopes as we did in example 3. So for example, the slope here would be 0, and that looks at about, 40 days. So at 40 days, here's your 0. So in trying to understand this graph, let's answer part A. What is the value of the derivative? Okay, so what is the value of the derivative? That's down here. Of the rabbit population in figure 3.010 when the number of rabbits is largest and is smallest. Well, the number of the rabbits is in blue here, and when that's the largest, well, we actually already talked about that. The derivative is going to be 0. The slope here is going to be 0. So the largest rabbit population, the derivative equals 0. The smallest rabbit population, that's down here, its derivative, the derivative here between, like, let's say 150 days and on, is also 0. Now the rabbit population isn't 0, but its slope is 0. The rabbit population is actually about 100, but its slope is 0. What are these values being measured in? Well, slope is the change in y values divided by change in x values. So the change in y values would be the number of rabbits, and the change of x values would be days. So the answers would be 0 rabbits per day and 0 rabbits per day. So when the population of rabbits hits a maximum here at about 40 days, it's not really changing at all. There's 0 rabbits per day for just a day, and then it starts decreasing. Or as the rabbit population levels out, it stops changing. It changes at 0 rabbits per day. Part B asks, what is the size of the rabbit population? So what is the size of the rabbit population? We're looking at a y value in f of x. When its derivative is largest, okay, the derivative is largest at 20 days. So at 20 days, the derivative is 40, meaning the number of rabbits is changing at 40 rabbits per day. But that's not what it's asking us. What is the size, the actual size? Not how is it changing, but what is the actual size of the rabbit population? That's up here. At 20 days, there are 1,700 rabbits. Now the derivative is smallest down here at, looks like 65 days. So at 65 days, the rabbit population is changing at about negative 55 rabbits per day. It's decreasing at 55 rabbits per day. But that's not what it's asking us. It's asking what is the actual population. Well, at 65 days, the actual population is, I'm going to guess it's about 1,300 rabbits. So again, looking at the connection between the two. At 20 days, the number of rabbits is 1,700 rabbits, but it is changing. It is increasing at 40 rabbits per day. At 40 days, the number of rabbits isn't increasing or decreasing. It's changing at 0 rabbits per day, but we have about 2,200 rabbits. At 65 days, we have about 1,300 rabbits, and those rabbits are decreasing at 60 rabbits per day. Then if we look out here as the rabbit population is leveling off, we have about 100 rabbits, but those rabbits are changing at 0 rabbits per day. So our f of x measures time versus the number of rabbits or wolves. Our derivative measures time versus rabbits per day. So in other words, on what day? So in other words, how many rabbits per day is our population changing at a specific time? So at day 150, our rabbits are changing at 0 rabbits per day. At day 0, our rabbits are changing at 20 rabbits per day, etc.